We're going to continue on with some more u substitution. This time, a couple of definite integrals are what we're going to start with. And so this time, we've only done just a general antiderivative where we need the plus c on the end, but we can also use u substitution if we have a definite integral. And actually, they can be a little bit easier when we do them. So I am going to choose my u to be the inside function, right, which is u is equal to x squared plus 9. My du then is 2x dx. So I only have the x and the dx, so I'm going to divide both sides of this equation by a half, so I get a half du equals x dx. Okay, so I'm going to rewrite. I'm leaving off my bounds for a moment. Okay, so I am going to swap this out. I'm going to call this u to the 1/2. And then for my x dx, I'm going to plug in a half du. So I'm going to put the half on the outside and the du here. Okay, now I have a choice here. If I'm going to write the 4 and the 0, then I need to write it as x equals 4 and x equals 0 because I'm in terms of u. But I think an easier way actually to do it, because if I use this method, then when I'm all done, then I have to put x back in and then substitute these in. But there's actually a way to actually not switch it back to x, and that would be to switch over my bounds right now. So I'm going to instead write this as a half and then u to the 1/2. I'm leaving off my bounds right now. So I know that my u is this, okay? These are x's. So basically u of 4, like this is my function, would be 16 plus 9, which is 25. So I'm going to replace my top bound here with 25 instead of the 4. And then on the bottom, I have 0, so u of 0 would then be, I plug in 0 for x, and that would be 9. So my bounds are like this, okay? So now I do the antiderivative here, so I'm going to add 1 to my power and get 3/2, and multiply by 2/3 at the same time, and this half at the same time, plus c. So in the end, my 2's cancel, and I get 1/3 u to the 3/2. Actually, I'm going to take away the plus c because I'm doing a definite integral. All right, so my 1/2 and my 2 from the 2/3 canceled my 1/2 out, and I'm just left with this. And now I'm just going to plug in my 25 and my 9. Now, if I decided to use this method, then I would have to put my x back in here, right? My x squared plus 9, and then plug in the 4 and the 0. But this kind of lets me avoid this plugging the x back in because I just converted my bounds to u. So, okay, so now I need to remember that this is going to be 1/3 and then 25. So this is 25 to the 3rd, but the square root of it. So the square root of 5 is, or 25 is 5 raised to the 3rd. So that would be times 125, and then minus 1/3 times, I plug in the 9. I get the square root of 9 is 3, and then I raise 3 to the 3rd power, so I'm going to get times 27 here. So basically I get 125 over 3 minus 9. And I don't believe that that's division. I'm just going to leave it like that. It's fine. Okay? So that's, I can do it this way, or once I get here, I have to come back. I get 1/3, and then I put the x squared plus 9 back in to the 3/2. And then I go back to the 4 and 0. Now I'm going to get exactly the same answer here, right? This one I didn't have to do this step because I just immediately put in my converted numbers. But here, right, if I plug it in 14, or if I put in 4 here, I'm going to get 1/3 times 16 to the 3/2, and then plus 9 times 1/3 to the 3/2. And I get the same. So if I simplify these two, then I get this back, okay? So just a thing to be careful with, right, is if you don't want to switch your bounds, then either don't write them or make sure that you write them like this, the x equals, because you have everything in terms of u, so when you put numbers on the bounds without the x, then that implies that they're for you, so be careful. Now, as a student, I prefer to always go back to this, but now as I have more experience, I actually find this method a little bit easier. So you can choose. All right, so I'm going to do some more u sub. So we have, this one is a little bit more complicated u sub. And so I notice, right, that normally, right, I would use the inside, and I am going to still use the inside here, which is x cubed plus 1. But I notice, ooh, this is kind of bigger, right? And I'm going to have some x's left over. But that's okay, because we can figure that out. So let's do some switching over. So I'm going to say u is equal to x cubed plus 1. So that means my du will be 3x squared dx. All right, so I have the x squared here. I'm going to call this, maybe it's easier if I call it x squared times x cubed here, okay? Because that's x to the 5th. So I have basically the x squared and the dx. So I'm going to divide both sides by 3. I get a third du is equal to x squared dx. Okay, so for right now, what I still have x cubed in here, and I have the square root of u, and I also have a third du. Okay, so the only thing that's holding me up here is, what do I have? Well, how am I supposed to get rid of this x cubed? Well, again, I come back here, right? And looky there. So I have an x cubed even in my u. So I can solve for x cubed in terms of u. So that would be u minus 1 is equal to x cubed. So that's my substitution for x cubed. So now I have a third, and then I have times, this will be u minus 1, and then I'm going to write this as a power, so u to the 1/2 du. Now I still need to change my bounds, so I'm going to do that too. I'm going to do it my way. So I'm going to plug in 2 here for x, right? So that would be u of 2 would give me 8 plus 1, so this will be 9 on top. And if I plug in 0, that's nice. U of 0 is just 1. So now I've got everything in terms of u. Now you might be thinking, wait, I still have parentheses and multiplication. And you would be right, but in this case, I can just multiply them together. I can distribute this u to the 1/2 through. So that would be 1/3 from 1 to 9. Then this is like u to the 1st times u to the 1/2, so that's where we add the power. So this would be u to the 3/2, and then minus u to the 1/2 du. And now I'm ready to go. So this would be 1/3. I'm just going to put the big bracket here because I don't need to multiply this through each one. I can just multiply it through at the end. So this would be u to the 5/2 times 2/5. And then this would be minus u to the 3/2 times 2/3. And now I'm going to put in my 9 and my 1. Okay, so I'm going to have 1/3 and then 2/5 times, when I plug in 9, the square root of 9, which is the 2 part, is 3. So then 3 to the 5th is, let's see, 3 to the 4th is 81. I think it's, let's see, we'll just plug it in here. How's that? 3 to the 5th is 243. And then minus 2/3, then this will be 9. The square root of 9 is 3 raised to the 3rd power. That will be 27. Right, so that's the, I'm going to put big brackets because that third is going to distribute. And then I have minus 2/5 minus 2/3. So, all right. So then after I do all that, then I can put this in my calculator and figure out what the number is. I'm just going to leave it to you to finish it. So let's do another. So I chose to do a few more of these where we have a little bit of extra something that we have to do with these. Okay, so in this case, my u is, right, this is the thing that's inside of something else. So I have x plus 5, and my du is dx because the derivative of x is just 1. So now I have, this will be u to the minus 3/2. I'm just going to write it like that immediately. And I can swap in my du for my dx. I just have this extra x hanging out here, which just happens to be over here. So I come back to here and I solve for x. That will be u minus 5. So I'm going to squeeze my u minus 5 in here, and I'm going to distribute again, just like I did the last time. So u to the first times u to the minus 3 halves will give us u to the negative 1 half, because we add our powers. And then I'll have minus 5u to the negative 3 halves du. So I just distributed this through my u minus 5. I kind of smushed it in there a little bit. Okay, so now I'm ready to do the antiderivative. Now I went back to indefinite integrals just to save us a little bit of time on doing these. Okay, so then this would be u to the 1 half times 2, because the reciprocal of 1 half is 2. And then I'm going to get minus 5 times u to the negative 1 half times negative 2. I just put in the reciprocal right away. So that will give me, now in these I have to go back to x, right? So I have essentially 2 square root of x plus 5, or you could just write x plus 5 to the 1 half. Either one is fine. And then I have negative 2 times negative 5, so I'm going to get a plus 10. And then if I want to put it, it technically could be written like this, because u to the negative 1 half is really the square root of u that's downstairs, right, in the denominator. And that is my answer. Right? So if you have a little something hanging out after you do the substitution, always go back to your original u equation and see, can I get rid of that somehow? Hopefully without making it more complicated. Okay, so let's do another one of those. So I always try out at least the thing that's inside of something else, and that would be the x squared minus 1. So u will be x squared minus 1. My du then is 2x dx. It's really important that you write this notation, otherwise you really don't know what you're swapping out, right? Because we are making a swap for this dx for du. Okay, so this leaves me to rewrite then. Okay, so this is my u to the 3 halves. I have that part nailed down. And then I only need one of these x's, so I'm going to call this as x times x squared. Again, kind of like I did before, right? Same thing. So I have an x and a dx to swap out, so I'll divide both sides by 2. And I have this. So now that means that this and this are now gone, and I can put in a half and a du here. But I still have this x squared, right? So I still have technically this here. Well, I don't want that there. I want everything in terms of u. So of course I go back here and I have this lovely x squared in there. So I know that x squared will be, I'm just going to add 1 to both sides. I get u plus 1. So I rewrite it as u plus 1 times u to the 3 halves. And now I need to distribute again, just like I did before. So, right, as long as these don't have, like if this parentheses had a power on it, I couldn't, unless it also had u to the, or it had the 3 halves power on it, I couldn't distribute it through. But since this is just a nothing to it, then I can just distribute through them. So this will be 1 half, and then I have u to the first times u to the 3 halves, which will give me u to the 5 halves, and then plus u to the 3 halves, du. And so I'll have 1 half u to the 7 halves times, I left some space there to put my reciprocal, and then plus u to the 3 halves, and then this will be 2/3 plus c. Right, so I have a little simplification. My 2's will cancel there, and this will be 1/7. I'll just start putting it back here, right? My u is x squared minus 1. So I have x squared minus 1 to the 7 halves, and then plus 2/3 times x squared minus 1 to the 3 halves plus c. And there we have it. Okay, so actually let's do this other one first. I think maybe this one is a little bit less complicated than that last one's the most complicated. All right, so we have another substitution here. So we haven't done many or any with logs in them, so I wanted to. Now we do not have an integral rule for logs. We know that the derivative of a log function is equal to 1 over x, but we don't know the integral. We don't know what the antiderivative of the natural log of x is. We have not done that, and if you take Calc 2, then you can figure it out later, but it uses a much more difficult technique than what we know right now. So in our cases, whenever we see the natural log of x, that has to be u, because the only thing I know how to do is take the derivative of it. So my u in this case is the natural log of x. So my du is 1 over x dx. So really, right, I could think of this as 1 over x times 1 over the natural log of x cubed dx. So I really do have the 1 over x here, right? So I can swap out this and this for my du, and then this will be 1 over u cubed, which I'll just write as u to the negative 3, and then I swap these out for my du. So now I just do the antiderivative. This is where I add u to the minus 2 divided by negative 2 plus c, and now I just plug u back in, which will be the natural log of x to the minus 2 over negative 2 plus c. All right, so we'll do one more that's a little bit more complicated here. Okay, so again, this thing being raised to the 12th, that's where I'm going to start, right? I always start here, and then if that doesn't work, then maybe I'll try something else, okay? So my u is going to be x cubed plus 1. That makes my du 3x squared dx. Now, this is a little bit complicated, right? But I do notice that these two things both have a common factor of x squared. So let's factor that out and rewrite it. So this is x squared times x cubed plus 4, and then this is still x cubed plus 1 to the 12th dx. All right, so all I did was factor out the common x squared here because I need it, okay? So I have the x squared and the dx, so I have these two pieces, so I'm going to divide by 3 and get a third du is equal to x squared dx. Okay, so right now, this is now gone, right? And I can write a third, and I'll put the du out here. I don't know what to do with this yet, but I know that this is u to the 12th. Oops, I don't know what I was writing there. U to the 12th. And then I still have this. I'm just going to leave it here for right now, x cubed plus 4 in here. Now, I'm doing the integral, the antiderivative with respect to u here, so I need to get rid of this x cubed plus 4. Now, I do notice here that I do have an equation with u and x cubed in it. So if I substitute, so I will have u minus 1 is equal to x cubed. So now I have 1/3, and instead of x cubed, I'm going to write u minus 1, but then there's still a plus 4 in there, right? So I have that, and then I have u to the 12th. I don't know why I can't write 12 today. There we go, du. So now let's simplify this inside. This is really just u plus 3 times u to the 12th du. And now I'm ready. Now I can just multiply through. So now I have a third times, still just simplifying my integral before doing it, u to the 13th plus 3 u to the 12th du. So this will be 1/3 u to the 14th times 1 over 14, and then plus 3 u to the 13th divided by 13 plus c. All right, so let's see. 3 times 14, that would give me a 12, 42. So I have 1 over 42, and then I'll put my u back. My u was, again, x cubed plus 1. So then I have x cubed plus 1 to the 14th. Yes, you are going to have kind of weird numbers in the denominator. That's pretty normal. And then plus 3 over 13 times x cubed plus 1 to the 13th plus c. So that's the most complicated example.